Why is the night sky dark? I mean, really think about it. Our galaxy alone contains hundreds of billions of stars. And beyond the Milky Way, there are billions, possibly even trillions of other galaxies, each containing billions more stars. That's an almost impossible number of stars. So if there are stars in practically every direction we look, why isn't the night sky glowing as brightly as the sun? The obvious answer is because it's night. The sun has gone below the horizon. Fine. But when Earth rotates away from the sun, we're simply looking in a different direction. The stars haven't disappeared. They're still surrounding us. So, why do we see mostly darkness? This question puzzled astronomers for centuries. Today, it's known as Olbers Paradox, named after the German astronomer Heinrich Wilhelm Olbers, who popularized the idea in 1823. Imagine standing in the middle of an endless forest. Look in any direction, and eventually, your line of sight should hit a tree. Now replace every tree with a star. If the universe were infinite, filled with stars, and had existed forever, then no matter which direction you looked, you should eventually see a star. That means light should be coming from every direction, making the entire sky bright. But it isn't. Why? The first explanation that comes to mind is distance. Maybe the stars are simply too far away. And that sounds reasonable. The farther away a star is, the dimmer it appears because its light spreads out over a larger area. But now, imagine surrounding Earth with larger and larger shells of space. The stars in each shell are farther away, so each individual star appears dimmer. But the shells are also much larger, which means they contain many more stars. The stars get dimmer, but there are more of them. Those two effects almost cancel each other out, so each shell would contribute roughly the same amount of light to the sky. If the universe were infinite, you could keep adding shells forever, and an infinite number of shells would mean an infinitely bright sky. So distance alone can't solve the paradox. What about clouds of gas and dust? Maybe they're simply blocking the light from all those distant stars, but that doesn't work either. If dust kept absorbing starlight forever, it wouldn't stay cold and dark. Eventually, it would heat up, and once it became hot enough, the dust would start glowing too. So even the dust would eventually light up the sky. The answer only became clear after we discovered something fundamental about the universe. It hasn't existed forever. About 13.8 billion years ago, the universe began expanding in an event we call the Big Bang. And this matters because light needs time to travel. Light is incredibly fast, moving at nearly 300,000 kilometers every second. But the universe is so enormous that even light can cross it instantly. Sunlight takes about 8 minutes to reach Earth. So when you look at the sun, you're seeing it as it was 8 minutes ago. The nearest star beyond the sun, Proxima Centauri, is so far away that its light takes about 4.24 years to reach us. Some of the light reaching your eyes tonight began its journey billions of years before Earth even existed. Now, imagine a star so far away that its light would need 20 billion years to reach us. The universe is only 13.8 billion years old, so that light is still on its way. It's not that the star doesn't exist, its light simply hasn't had enough time to get here. This means we don't see light from every star in the universe. We can only see the part of the universe whose light has had time to reach us. That's what we call the observable universe. Everything beyond that is simply too far away. Its light hasn't reached us yet, so we can't see it. And that's why, despite all those stars, the night sky is still dark. But there's one more part of the puzzle. The universe isn't just getting older. It's also expanding. Imagine drawing dots on the surface of a balloon. As you inflate it, the dots move farther apart because the surface between them is stretching. The expansion of the universe works in a similar way. And when space expands, it stretches the light traveling through it. This is called redshift. As light gets stretched, its wavelength becomes longer. Visible light can be shifted into infrared. The light from extremely distant galaxies can be stretched beyond what our eyes can see, into infrared, radio, and other invisible wavelengths. If humans could see infrared and radio waves, the night sky would look very different. So the night sky is dark for two simple reasons. Light from some stars hasn't had enough time to reach us, while some of the light that does reach us has been stretched into forms our eyes can't see.